Welcome to our talk, Serverless Spyglass. Today we're going to share how we created visibility into our step function executions using already existing observability tools. Whether you're like us, cloud engineers responsible for managing serverless workflows, or site reliability engineers concerned with the uptimes of services, or tech leads focused on the user experience, this talk is for you. We hope by the end of this talk, you'll be able to create your own serverless Spyglass. My name is Tanya Vo, and I started out in Fidelity's LEAP graduate program as a career changer and been working as a junior cloud engineer for the last 2.5 years.
Hi everyone, I'm Aravind Silvaraj and I'm a principal cloud engineer at Fidelity with over 15 years of software development experience. Tanya and I are part of a cloud engineering team responsible for AWS account creation and its capabilities management across the organization. We right now manage around like 1,700 accounts at the moment within the firm. Yeah. We basically specialize in building like highly scalable, distributed serverless applications using various services, but mostly using step functions. It is the main key to go service of ours. Yeah. While serverless offers us, like, as I said, scalability and reduced overhead, it also presents us with a unique observability challenge. Because with so many decoupled components, tracking a request at some time can feel like a puzzle. But before we actually move on, let me ask you, like, why does observability really matter in a serverless architecture? Is it just to find and fix errors, or is there something more to it? Yeah. So from experience, right, using step functions and all the distributed services, we have seen that as a workflow grows, it actually gets harder to monitor. And it usually requires like proactive monitoring to reduce downtime. This is where like the observability helps us. It basically does detect, diagnose, and reduce or resolve issues faster, and ultimately like improves the customer and developer experience. This is done by following like 3 key pillars of observability: metrics, performance used for like identifying like a performance and operational health. And logs, we all know of, used for troubleshooting, and traces to get like end-to-end visibility into our distributed services. All right. Now that we heard about like what observability offers us, Tanya will do a deep dive into like what our observability problem was and how we tackled it.
For you to better understand our observability Spyglass, we first need to talk a little bit about what we're actually trying to observe. Serverless workflows include step function flows, which offer us many advantages like native integration, quick spin-up time, and the ability to easily add new functionality, which I'm sure many of you here will agree. We have several workflows, which we call parent flows, that each consist of their own nested child flows, which are workflows unto themselves. In fact, one of our parent flows has over 40 child flows. This serverless architecture gives us scalable and feature-rich applications. However, this alone is not a complete solution. As with any answer to a complex problem, maintenance and thus observability are essential components to form a total serverless solution. Meaning, as your workflows evolve, your observability should keep pace. Let me ask, who all here has been on on-call support? So mostly everybody. So like Arvind and I bet you're crossing your fingers. You hope you don't get an urgent alert. But when an alert does come in, stakeholders always ask, what happened, why, and of course, how fast can you fix it? Actually, the inspiration for this talk was born of our team's need to see step function execution details at a glance, because we knew this would simplify our troubleshooting by pointing out issues directly for us. Next, let's talk about different types of observability tools available to us and to you. Custom tools like scripts can be modified to fit your in-house infrastructure. However, they do require a bit of bespoke development. While third-party tools include observability platforms like Datadog, which offer central monitoring for logs, metrics, and traces, and even offer you templates to easily create your monitors. and even have pre-built serverless dashboards. This was desirable to our team because we wanted everything in one location to easily monitor the health of our application and manage our monitoring. Manage our monitoring. However, third-party tools do require a little bit more effort and may have additional costs. For instance, X-ray traces do require a little bit of extra work to propagate into third-party platforms, and sending lots of logs or highly detailed logs can have associated costs. And let's not forget about native tools offered by AWS. AWS Native Observability offers out-of-the-box tools, which is great for developers new to serverless since it generally just works with a little bit of configuration, because they are built into AWS services like Lambdas and step functions. Native tools include CloudWatch logs and X-ray traces, which are available as hyperlinks, as you can see here on the Execution Detail tab, and CloudWatch metrics on the Monitoring tab, all from your AWS console. Though native tools do require a little bit more effort to navigate between different observability points, you can easily use them for troubleshooting and development like our team did. To create our workflow observability, our team decided to use a combination of custom, native, and third-party tools to monitor the three observability pillars. Firstly, metrics are a numerical representation of data over time. Like you can see here, error rates and latency are two common metrics. Metrics gave us a snapshot view of our application, and it enabled us to not only create alerting, but also understand trends ahead of an issue. We use the native metric AWS states execution failed, a custom script, and a third-party monitor. So if an execution failed in the current time window, it would trigger a monitor and send us an alert, so we'd immediately know one of our step functions failed. This was quick and easy for us to set up. However, as our application matured, we encountered a situation where more than one execution failed at a time. Our pain point was linking an alert to a particular failed step function execution, which we found was prolonging troubleshooting and thus incident resolution. So what we needed was a finer Spyglass. And this is where logging steps in. Logs are time-stamped record events with detailed transaction messages. We used CloudWatch logs, a custom script, and a third-party log monitor to create this alert here for a failed step function execution. We were able to use log attributes to pull out the execution ID, error messages, and even have direct links to the execution ARN and logs, all in one email alert. Just keep in mind, third-party monitoring does require a little bit more configuration, like correct logging level, log foldering, and enabling a forwarder to send your logs. But we found this greatly streamlined our troubleshooting, so it was well worth the effort.
All right. Now that we heard about the fancy metrics and logs, right, which we are all familiar about, let's have a look at this beautiful X-ray trace map of our parent workflow. As you can see, it is showing connecting the dots between various distributed services, with each node representing a different AWS service, and the arrows basically showing the connection between them. This is, unlike metrics and logs, as you saw, which gives you a snapshot of performance and events, these traces can give you the end-to-end visibility into the user journey. It can help you answer some critical questions also, like there is a bottleneck in my system, or how does one service failure impact others. However, traces are just one piece of the puzzle. For true observability, you need a powerful combination of metrics, logs, and traces.
We know that was a lot to take in 10 minutes, so let's quickly summarize our talk. You can use, to create your step function execution observability, you can use a variety of observability tools and pillars, which can give you insights into your workflow's performance and help you expedite incident resolution. Overall, observability gives you a reliable and complete solution by enabling you to properly monitor and maintain your serverless workflows, because you always have an up-to-date Spyglass view of your applications. Before we go, Arvind and I want to leave you with a few action items. Please take a look at your serverless workflows and see if you can use any of the tools and pillars we talked about today so you can create your own serverless Spyglass. Thank you again for listening to our lightning talk. And if you'd like to learn more about what you heard today, observability, or the tools, please scan the QR code. Thank you again, and we hope you enjoy the rest of your serverless day.
Right. Thank you.